This video is on quadrilaterals. Quadrilaterals with a root of quad there means they have four sides. A common quadrilateral is a parallelogram. In a parallelogram, opposite sides are parallel. So parallel doesn't mean they're straight up and down. It just means they're at the same slant. They're parallel to each other. Something called a rhombus is a parallelogram with equal sides. So it's like the square version of a parallelogram. A rectangle is a parallelogram with perpendicular sides. So not only are the opposite sides parallel to each other, but also they intersect at 90-degree angles. They intersect perpendicularly. A square is a square. It's a rectangle with all of the sides being the same. A trapezoid, two of the sides are parallel and two aren't. So in this case, the top and the bottom are both parallel, but the sides aren't. We could actually turn that on its side. That would still be a trapezoid. It would just be the left and right sides would be parallel and the top and bottom wouldn't be. The two parallel sides are called the bases. One more thing on this list is just a general quadrilateral. So quadrilaterals can be irregular. So all of these have specific cases where they have some parallel sides. But if we didn't have something like that, my drawing is particularly ugly. But we could have a shape like that looks probably a little bit too close like a trapezoid. Let me try again. Something long, something short. There we go. So this quadrilateral doesn't follow any set formula about how to find the area of it. So what we have to do is we have to be a little creative. But first, let's talk about the area of these other shapes. The area of all of those, except the irregular quadrilaterals, and except trapezoids, the area for everything else is the base times the height. So being really specific, what I mean in a parallelogram, one of these sides is the base. It doesn't matter which one. So let's say this is the base. And then the height would be something that would meet at a 90-degree angle, something that would meet at a right angle. So base times height for parallelograms and rectangles. For trapezoids, there's a little twist on that because the bases are uneven. So what we end up doing to find the area is we could follow this formula. 1/2 of the height equals b1 plus b2 for the two bases. I want to note that our book doesn't call these B1 and B2. Our book says A1 and A2, but it's the same thing. Another way of thinking about this formula is to put it in this form here, which I actually like more because it's easier to see that what we're doing is we're taking the average of the two bases, base 1 and base 2 divided by 2, and then multiply that by the height. So if this is base 1 and this is base 2, we just take the average of those two lengths, add them, divide by 2, and then multiply by the height. And the height is not the slant height here. The height is instead an altitude. That's the distance between the two parallel sides. So that means in this second trapezoid that looks a little funny because we don't usually see it this way, one of these two sides are our base, and this right here, the distance between those parallel sides, is the height. I don't care that it's on its side. We can turn the figure, but the measurements still remain. For the perimeter of any and all of these shapes, what you do is add up the lengths of the sides. Some of you may say, but wait, the perimeter of a rectangle is 2 times L plus 2 times W. Well, if you have a rectangle, that's exactly what that is. There's two lengths there and two widths there. So still, what you're doing is you're just adding up the lengths of all the sides. One heads up, rounding rules are back. So if you're adding, you need to look to the precision. So if you're finding the perimeter, you should be looking to the precision of the numbers. And if you're multiplying or dividing, look to the accuracy, the number of significant figures. Let's do one example problem. Each hospital bed and its accessories use 96 square feet of floor space. How many beds can be placed in a ward 40 feet by 60 feet? And the decimal at the end means that those zeros are significant. So I see this is two significant figures, two significant figures, two significant figures. Our answer should also have two significant figures. So, especially with geometry problems, it's so frequently useful to draw some kind of a picture. So this is not to scale, but this is 40 feet by 60 feet. And what we want to see is how many rectangles of some sort or another of 96 square feet we can fit inside of that. So what I want to find is I want to find the total area, which in a rectangle is base times height, so 40 times 60 is 2,400 square feet. And now I want to take that 2,400 square feet and divide it by 96. So we have square feet divided by square feet, and the answer here is 25. So 25 hospital bed units can be fit into this space. Thank you.